Hello everyone, this is Archie, and welcome to DevDive. In our daily lives, we all deal with a vast amount of information stored across numerous PDF files. However, when it comes to using advanced language models, LLMs, like ChatGPT, we often face a significant challenge. These models aren't trained on our personal data. This lack of contextual awareness means that the responses we get from LLMs are generic and not tailored to our specific needs or past interactions. In other words, the LLMs don't know our data, leading to answers that might miss the mark in terms of relevance or accuracy. But what if there was a way to bridge that gap without the need to retrain these complex models? That's where my project, ChatPDF, comes into play. By leveraging this approach, we don't need to retrain the models on our data. Instead, we create a context store, a repository of relevant information that acts as a knowledge base for the LLM. When a query is made, the system first searches this context store for relevant information, combines it with the user's query, and then passes it to the LLM. This results in more accurate and contextually relevant responses, tailored specifically to the data you care about. Let's dive into how we can achieve this. The implementation is straightforward, but powerful. We will be using several key libraries: ChromaDB for vector storage, LangChain, and Ollama as our language model. If you haven't set up Ollama yet, be sure to check out my previous video where I walk you through setting it up on AWS. We're going to write two scripts, one to create our context store and another to retrieve relevant context and query the LLM. First, let's create the context store. Step 1. Load the PDF file from the data folder using a loader provided by the LangChain community. Step 2. Split the content of the PDF into smaller, manageable chunks using a text splitter. We'll call these chunks documents. Step 3. Next, we'll generate embeddings for these documents. Embeddings are vector representations of the data, essentially numerical fingerprints of the text. For this, we'll use Hugging Face BGE embeddings. Step 4. With the documents and their embeddings ready, we'll store this information in a vector database using ChromaDB. At this point, you've successfully created a vector store containing your data, making it ready to serve as the context for future queries. Now, let's move on to the second script that will pull context from this store and query the LLM. Step 1. Since this is a CLI tool, we'll start by setting up an argument parser to handle the query inputs. Step 2. We'll prepare our vector store and set up the same embedding function we used earlier. Step 3. When a user enters a query, the script will run a similarity search on the vector store to find data that's relevant to the query. Once we've identified the relevant context, the next step is to craft a prompt. Step 4. We'll create a prompt template that includes the context, the user's query, and clear instructions on how the LLM should respond. Finally, we pass the prompt to the LLM. In this case, we're using Ollama. To initialize it, you need the URL of your Ollama server and the specific model you're using. Then, simply invoke the model with the crafted prompt, and voila, you have your response. Let's see this in action. Suppose I'm working with a novel, and I ask, "Tell me how many chapters are there in this book?" The system searches the vector store, gathers relevant information, queries the LLM, and just like that, it tells me there are 12 chapters in the book. And there you have it, an intelligent way to chat with your PDFs using the power of LLMs and vector storage. But this is just the beginning. I'm working on a web UI for this amazing CLI tool, so make sure to stay tuned for that. If you found this helpful, please like, share, and subscribe to stay updated on future videos. Thanks for watching, and happy coding!